Solve example on steam power plant. Steam at 40 bar 500 degree centigrade flowing at the rate of 5500 kg per hour expand in a high pressure turbine to 2 bar with an isentropic efficiency 83%. A continuous supply of steam at 2 bar 0.87 quality and the flow rate is 2700 kg per hour is available from a geothermal energy source. This steam is mixed adiabatically with the HP turbine exhaust steam and the combined flow then expand in a low pressure turbine to zero point 0.1 bar with an isentropic efficiency 78%. Determine the power output and the thermal energy of the plant. Assume 5500 kg per hour of steam is generated in a boiler at 40 bar 500 centigrade from the saturated feed water at 0.1 bar. Had the geothermal steam not been added, what would have been the power output and efficiency of the plant? Now the pump power is neglected. So from the diagram we know that high pressure turbine 40 bar 500 degree centigrade and the flow rate, and this 2 bar and steam at 2 bar and 0.87 dry enter here, and this both enter in low pressure turbine, and the output of low pressure turbine 0.1 bar. This is condenser, flow rate is given here. Now from this is the diagram, 40 bar 2 bar and 0.1 bar. This is the 40 bar entrance on high pressure turbine. Then the exhaust of high pressure turbine is 2 bar. This is the high pressure turbine exhaust 2 bar, and then exhaust of low pressure turbine is 0.1 bar. This is the exhaust of low pressure turbine at this point is 0.1 bar. Temperature 500 degree centigrade. The temperature is 500 degree centigrade. Then enter this point 2, and then this becomes, this is the TS diagram. Now from here we know that H1, S1 and K. Then we have to calculate X2. H1 is the enthalpy, entropy. This can be calculated with use of steam table. At the point 1 we know that pressure and temperature. At given pressure and temperature we can calculate entropy, enthalpy, and then the value of K can be calculated, and X2 can be calculated through the same isentropic process. Same line we can calculate the point of 2s. Then H2 can be calculated after X2 calculation. H2 can be calculated, then H1 minus H2 can be calculated. Now after this H3 and H4, where is the point? This is one point, is the H1, this is H2, This is H3 and H4, and here is a H5. These are the points, and this is the H6. 1 2 3 4 5 6. Now from here we can calculate x4, then s4, then 5 and 6. All points can be calculated from the given diagram. Now last part we have to calculate, determine the power output and thermal efficiency. We need to determine efficiency. So efficiency is W upon Q. Q is equal to flow rate into H1 minus H6. Here is the H1 minus H6, because it is a heat addition into the boiler Q1. H1 minus H6 is equal to Q1, and work output W. What is the W? W is H1 minus H2 plus H4 minus H5. Here is a flow rate at that point is 55,000 kilogram per hour, and then H1 minus H2, and H1 minus H2, and then H4 minus H5, and then the flow rate is addition of this plus this, it become 8200. So from this diagram W can be calculated. Then efficiency is 35.3. Then cycle efficiency WT or Q1. Then WT can be calculated, turbine work done, and Q1 H1 minus H6. We have no. Then this is cycle efficiency.